Hi, this is Michael King. We're back looking at another application of time value money, which is mortgages. Mortgages are also an application of the annuity formula. Okay, so a mortgage is actually a type of loan, except it is secured by real estate. Now, mortgages have a different type of compounding, and they also have more frequent payments. So the compounding is going to vary. In Canada, we use semi-annual compounding. So remember that M in that formula is for getting the effective interest rate is the number of compounding periods per year. We're going to set M equal to 2. We also have to adjust because we're making monthly payments. And so F in that effective interest rate formula is going to be equal to 12 because there's going to be 12 payments per year. So that's why we looked at that quoted to effective interest rate example in one of our previous classes, where we looked at semi-annual compounding with 12 payments per year. You need it to calculate what interest rate is going to be charged on a mortgage in Canada. Now there's some other terminology. When you take out a mortgage in Canada, they describe the term and they describe the amortization period. This can be confusing because the term is not the full period of the mortgage. It is only the period over which you've locked in your interest rate. So in Canada, you typically get a 5, 7, or maybe a 10-year term on a mortgage. The amortization, however, is the full period life of the mortgage, or how long it's going to take you to repay it. So you might have a 25-year amortization or a 30-year amortization. So notice that the term is shorter than the amortization period. What this means is that at the end of the term, you have to renew your mortgage and you'll have to set a new interest rate. When calculating your mortgage payments, however, we're going to assume that the interest rate is going to be fixed over the whole life. Even though it's a 10-year term in this example, we're going to calculate our payments based on the 25-year amortization, assuming the interest rate is going to be the same. Now, if you have a $500,000 mortgage in this example, and a quoted rate of 5%, compounded semi-annually with monthly payments, we need to figure out our payment. We're going to have to figure out, first of all, what our effective monthly rate is going to be, and then we're going to plug that into the annuity formula. So, first step, calculate what the effective interest rate is going to be, which is K. Okay, so we know that the quoted rate is 5%. Compounding, or M, is equal to 2. Number of periods, or payments per year, is 12, so F equals to 12. So plugging that in, we see that our monthly effective rate is going to be 0.4124%. Okay. Does this make sense? Well, if you were to multiply 12 times 0.4, you would find out what your rate actually is going to look like over 1 year. Okay, so step 2, we calculate the number of periods. Even though it is a 25-year amortization, there are monthly payments, so 12 payments per year. So here, N, or number of periods, is going to be 25 years times 12 payments per year, or 300 periods. We're going to need that for our annuity formula. Step 3, we use that annuity formula to calculate our monthly payment, assuming that the interest rate is fixed over the life of the mortgage, or the 25 years. Okay, so we have our annuity formula. Here, we know that the present value of the mortgage is $500,000. We know that the effective monthly rate is going to be 0.004124, which we solved for in the previous period, or 0.4124%. We know that the number of periods is going to be 300, which is 25 times 12. Solving for our equal monthly payment, we get $2,908.05. Step 4 is to create our amortization table, similar to what we did with the loan. There are going to be many more periods, however, because this is going to be monthly, and there's going to be 300 periods in total. Okay, so we plug in what we already know. We know that we're starting with a beginning principal amount of the mortgage of $500,000. We know that the payment is going to be $2,908. Next, we calculate how much of that payment is going to be interest. We multiply the beginning principal amount times our effective rate for 1 month of 0.4124%, and we get that out of that $2,900, we're paying roughly $2,062 in interest. So the remaining amount must be the principal repayment, or $846. So at the end of the first period, our balance has been reduced to $499,153. This becomes the beginning principal amount for the second period. So you just continue to fill it in, using the end principal amount to be the principal amount at the start of the next year. Your payments are equal amounts. You have to recalculate the interest portion, you recalculate the principal portion, and then you can figure out the end amount outstanding. So let's take a look. Here's an example where we're showing the first 4 periods and the last 2 periods out of a 300 period mortgage. Notice your $500,000 in the top left. Notice that at the very bottom you have $0 remaining, meaning that at the end of the 300th period you've repaid your mortgage completely. Notice that your interest payments are going to be declining. They start out to be $2,061, they go down to $2,058 in the second period, and so on. The reason is that the principal amount is dropping. How much is it dropping by? Well, look in column 4, you can see it starts off by dropping by $846 in the first period, $850 in the second period, and so on. And your end principal balance outstanding is declining as well. In the very final period, or period 300, you start off by owing $2,896. Your payment is going to be that equal amount of $2,908, of which only $12 is going to be interest, and the remainder is repaying the outstanding amount of your mortgage. If you were to plot how much of your equal payment of $2,900 is principal versus interest, you'll see that the lower gray amount is, the darker gray amount is the amount of each payment that is interest. And you can see that it starts roughly around $2,000 and goes down over time. And the remaining amount of your payment is actually your principal repayment. And you can see that it starts at around $850 and it increases over time. So if you're ever asked to double up on your principal payments, or to repay a part of your outstanding amount, you should, because you will be reducing the amount of interest paid over the life of the mortgage due to compounding. Okay, so what's your amount outstanding at the end of the 10-year term? Remember that you had to refinance at the end of 10 years. So this is simply a present value calculation where you have to calculate the number of periods remaining. So with 10 years gone, that means you have 15 years remaining with 12 payments per year, so 180 periods. So what's the present value? Well, we know what our payment is going to be. It's $2,908 for each period. We know what our effective monthly interest rate is. It's 0.4124%. And we simply have to plug in the new number of periods remaining, 180, and we find out that our mortgage at the end of 10 years is $368,977. So what that means is that you have paid off $131,000 over the first 10 years of this mortgage. Here you can see that it's simply the difference between the starting amount of your mortgage, $500,000, minus your balance outstanding at the end of 10 years. That's how much you've actually paid off. So when calculating mortgage payments, don't forget to do these steps. Calculate the effective interest rate, calculate the number of periods, figure out your payments using the Annuity Formula, and then calculate your amortization table. It's complicated, which is why mortgages are a very difficult financial instrument, but it is one that hopefully you will be faced with soon when you buy your first house. Good luck, and that's it for today.